All right, L'Hopital's rule number 1. This looks like a review. We just want to simplify the expression. So we have d squared minus e squared over dE all over d minus e over e. So we will do keep, change, flip. I will also factor out difference of squares here. So this will be equal to keep the top. I'm going to factor this out because I see a d minus e difference of squares will give me d minus e times d plus e over dE. So you keep the top, change division to multiplication, and then we're going to flip this bottom fraction. I'm sorry, I didn't put that division bar. We're going to flip that. So the e is going to be on the top, and then the d minus e is going to be on the bottom. So we'll divide out an e, divide out d minus e, and then this will simplify to d plus e, that's the only thing left, over d. So we just kind of simplified that fraction down. Right, number 2, it wants to explain the steps used to apply L'Hopital's rule to a limit of the form 0 over 0. So it says rewrite the quotient as a product, then take the limit of the derivative, take the limit of the quotient of the derivatives of the numerator and the denominator. That looks about right. Take the limit of the quotient of the numerator and denominator. Take the limit of the derivative obtained using the quotient rule. So you don't use the quotient rule, you just take the limit of the quotient. So you still do that division problem of the derivatives of the numerator and denominator separately. All right, here we want to explain how to convert the form 0 times infinity to a limit of the form 0 over 0 or infinity over infinity. So it just says suppose f times g has an indeterminate form 0 times infinity, where the limit a goes to 0 for f of x and the limit g goes to infinity. We're going to write, so this is the way the textbook showed it. If I have f times g of x, we're going to write this as g to the negative 1 power. We're going to rewrite it, so this will be f over 1 times g of x. Now, as g of x goes to infinity, this fraction overall goes to 0. So we're going to just rewrite it in that term. So it says rewrite limit a, and then we're going to do f of x over 1 minus g of x. And so as the limit of this, okay, or I'm sorry, you can do both forms. So 1, if we want to get it to in the form 0 over 0, we'll write it 1 over g of x. If I want it to be infinity over infinity, I want to do that opposite. So as the bottom is going towards 0, this whole fraction is getting bigger. So the mindset when we talked about limits earlier is if you have 1 divided by 0.1, that's going to give you 10. If you have 1 divided by 0.01, that's going to give you 100. And so as this number on the bottom is going smaller and smaller towards 0.001, the bottom is going bigger and bigger and bigger toward infinity. Okay, so that's the mindset that they want you to kind of understand. You can do either way, and they both work out. So g of x was already going toward infinity. So if you do 1 over something really small like 0, that goes toward infinity. And then after we do that, we will apply L'Hopital's rule. So you can rewrite it first, and then we apply L'Hopital's rule.